Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in Engineers in Progress. I hope that this set of problems can improve your thinking skills, especially in mathematics. About uniform motion problems. So here is the first one, 37. The principles and theories were discussed in the first part of this uniform motion problem video. Jo Beth left her college town on a bus that traveled 60 miles per hour. 3 hours later, her father left home, driving at a speed of 50 miles per hour to meet the bus. If the college was 345 miles from Jo Beth's home and the father met the bus as it arrived at the station, how long did the father drive to meet the bus? So, my solution here is not so detailed so that the viewers would be able to think of how I set up the equations because that is very important in training your minds. By the way, for those who want to anticipate or solve the set of problems here, there are four. You may do so by pausing the video. And for those who will just listen, you just look at and watch the video. So the distance is 345 miles, and this is the distance traveled by the bus plus the distance traveled by the father. They only differ in travel time. For the bus, the travel time is t plus 3 hours ahead than Jobet's father because the travel time of her father is t, which is unknown. So distance equals speed times time. So d is distance traveled by the bus plus distance traveled by the father. And d here is equal to 345 miles. The distance traveled by the bus is speed of the bus, which is 60 miles per hour. Then travel time is, as I said, t plus 3. So 345 equals 60 times t plus 3, where t is the travel time of the father. And the bus, take note, the travel time of the bus is 3 hours more than that of the father's travel time. So plus 50 times t. Simplifying, 345 equals 60t plus 10t is 50t is 110t, and 345 minus 60 times 3180 is 300. So 345 is 110t plus 180. 60 times 3 is 180. Then 180, 345 minus 180 is 165, and the right side 100t. So t therefore is 165 over 110. That's the travel time of the father, which is 1.5 hours. So that's it for that problem. Problem 38. At what rate must a car that is 20 feet long travel in order to pass in 3 seconds a track that is 35 feet long and traveling in the same direction at 55 miles per hour? Time starts when the front of the car is even with the rear of the truck, and it ends when the rear of the car is even with the front of the truck. So in this problem, I'll solve this in more detail. So let's have the figure so that you can also analyze the situation. So we have a car that is 20 feet long, and it starts when the front of the car is even with the rear of the truck as shown, and the truck is 35 feet long. Then, in 3 seconds, the car should be ahead of the truck, completely overtaking the truck when the rear of the car is even with the front of the truck as shown in the figure.
So this this was the front of the truck. This is the final front of the truck. Then in 3 seconds, that's the distance traveled by the truck. And it is speed of the truck times time, which is 3 seconds. So that distance there. While for the car, this was the front of the car, and this is the final position of the front of the car. And this distance is speed of the car v sub c times 3 seconds. Then from the figure, this 3 times v sub c, this total distance here, is equal to 35 plus 3 times speed of the truck plus this distance, which is not labeled here, but this is 20 feet. So again, 3 times v sub c is equal to 35 plus 3 times speed of the truck plus 20 feet. So that is 3 times v sub c equals 55 plus 3 times velocity of the truck or speed of the truck. The speed of the truck is 55 miles per hour. To be consistent, we should convert this 55 miles per hour to feet per second. 1 hour is 3,600 seconds. Then we multiply this further by 5,280 feet, which corresponds to 1 mile. And the speed of the truck in feet per second is equal to 242 over 3 feet per second. Substitute here, 3v sub c equals 55 plus 3 times 242 over 3. So 3v sub c equals 297, therefore v sub c is 297 over 3, and that is 99 feet per second. We then convert this to miles per hour because we should make the units same as that of the speed of the truck. So times 3,600 seconds per hour, then times 1 mile, 5,280. So the speed of the car or the rate of the car so that it will overtake the truck completely in 3 seconds is 67.5 miles per hour. So that's it for that problem. And problem 39, this is the last problem for this video. A small plane was scheduled to fly from Los Angeles to San Francisco. The flight was against a headwind of 10 miles per hour. Threat of mechanical failure forced the plane to turn back, and it returned to Los Angeles with a tailwind of 10 miles per hour, landing 1.5 hours after it had taken off. So this 1.5 hour is the total travel time going forward and going back. If the plane had a uniform airspeed of 150 miles per hour, remember that's airspeed, so that means it is the speed in still air. How far had it gone before turning back? So take note that the distance uh, from Los Angeles to the point where the small plane returned is equal to the distance from the point of return to Los Angeles. So same distance. So call it distance forward and distance back. So D equals distance, F equals distance in going back. And distance is, yes, that's the distance. And also, time in going forward plus time in going back is 1.5 or 1.5 hours. Remember that that time is distance over effective speed or effective rate. The effective rate is airspeed plus minus the wind, the effect of the wind. If it is tailwind, so plus. If it is a headwind, it is minus. So in going forward, the plane uh, encountered a headwind of 10 miles per hour, so the effective speed is 150 minus 40. So since distance is the same, going forward, going back, so we'll call that D. So D over 150 minus 10 plus d over 150 plus 10 equals 1.5. So this is simplified into d over 140 plus d over 160 equals 1.5. So actually, we can compute this using your calculator. There's to solve this in a short while. So with your calculator, you have to type 1.5 divided by quantity 1 over 140 plus 1 over 160. So that's the distance. And the distance is equal to 112 miles. So that's it for this video. I hope that you were able to follow the explanation and solutions.